All right. Okay, drinking Red Bull and doing microcontrollers. That's true nerddom. Now, do we have security to help safeguard to give out hardware? Oh no, I see. Mix some muscle. Ooh, okay. We're ready, we are. Tell me, what about the 10 seconds? We already did that. We're good. Okay, fantastic. All right, hey, appreciate everybody coming here today. Not quite the wall-to-wall crowd, but hey, the good news is I got hardware to give away. See, there you go. Oh, here they come now. Here they come now. Okay, so the good news is a lot of you are going to get hardware. I don't have like 100, but some of you will get some hardware, so that's a good thing. One of the things I want to share with you guys, if you have not done it already, especially if you're watching on video, be sure to check out Johnny Long's talk that kicked off DerbyCon. That was, without a doubt, an awesome talk. Very, very encouraging. And I'll tell you, I talked to Johnny. One of the things he talked about is he wants to do a hackerspace there in Uganda. And I was already trying to donate some hardware to him to help him with his auction. So, if there's any any STM32 experts here? My blue ribbon panel over there is like scratching their head, checking out their shoes. But we do have some experts here, so that'll help us out. But I actually tailored this presentation a little bit to help lend itself to supporting Johnny and his effort. And, Johnny's talk is, I'm telling you, man, it's inspiring. And, it says a lot about, doing good things for others, that just because you're a geek doesn't mean you can't make a difference in the life of others. And man, I just love you for what you're doing. And all right. Oh, you read my mind, man. Thank you so much. Woo-hoo. Oh, man.
Knock it up.
All right. Woo. Man, I tell you, I was hoping that he would know what I was thinking, and he did, man. When you need a hug, he's a great hug. Now, I heard Dave Kennedy's pretty good, but I think Johnny, he's got nothing over Johnny. Now, I got to tell you, if you've never been hugged by Johnny Long, let me try to describe it for you.
Well, it's big and terrible. More frightening than I ever thought possible.
Okay, that didn't pick up very well, but oh well. It's big and terrible and more frightening than I ever thought possible. So that's for the record. Okay. So let's get started here. I'll tell you what, we could have, this is DerbyCon, we could have a Microcon. We could have a conference about nothing but microcontrollers, and we could easily fill the conference. There is so much to talk about. What I'm hoping to do in about the 50 minutes that we have is kind of give you guys an intro to some of the stuff that's out there, kind of get you kick-started. There's more detail in here than I normally like to talk to in slides, but you'll be able to pick that up on the video later, so don't worry about URLs. You can go pick that stuff later. And this is the challenge that I have as a speaker. If you go to college, you take the speech classes, they're going to teach you that, hey, you've got different kinds of speeches. One of them is a motivational speech. And this is intended to be a motivational speech. My hope is that at least half of you guys here will go out and actually play with microcontrollers. And when you have hardware to give away, that kind of makes it a little easier, right? So you'll be motivated. So, all right. So let me talk about how we're going to do this. This is going to be highly interactive. It makes it real hard for me to figure out how long to make the material. But I do want this to be interactive because, after all, I'm not up here to talk about stuff because I want to hear my own voice. I assure you I don't. So I'm going to have periodic breaks where I'm specifically going to stop, and we'll do some Q&A. Okay, and let me introduce my blue ribbon panel here. Ed and Mariano, could you guys stand up, please, so everybody can recognize it? Mariano's like, I don't know if I want to. These are Ed I work with. He's a fantastic guy. Mariano is a friend of Ed's. And if he's a friend of Ed's, he's a friend of mine. Everything I know about Mariano is fantastic. These guys are embedded folks. I asked if they'd be willing to come, and after we're done, we're going to exit out to the main area. If you got questions, feel free to ask myself or these gentlemen. They can help you out. And Johnny, they are STM32 guys, so they might be able to help you with those kits that we were talking about. So, All right. And yes, the rumors are true. There is, in fact, hardware to give out. Smiley face. Thank you very much. Now, I am going to save maybe about 5 to 10 minutes at the end for like a final Q&A session, right? We'll try to get some quick ones in, but at the end, we'll kind of open it up to whatever. And I'll tell you what, this talk really is for you guys. If there's something you guys need, we can pitch the slides, right? Because this is really about your interest and where you guys want to go. Now, why is this guy standing in front of you, and where does the name Tharon even come from? Well, that's a whole different story, but I'm a self-declared microcontroller evangelist. Believe it or not, I've been using microcontrollers since the late 1980s. And you guys know what that means, right? I'm old. That's all that really means. And I can tell you guys, when I first started with microcontrollers, I was working at big companies. You might have heard of some of them, like General Motors, IBM. And we used pieces of equipment that were thousands of dollars, all written in assembly from tools that cost, I don't know how many thousands of dollars. The idea that a guy at home could pick up a microcontroller and start doing anything was just beyond anybody's comprehension, okay? Now we've come to a time, in some ways this is one of the best times to get into microcontrollers because there's so many fantastic options. There is one big downside, and we'll talk about that. But I have worked in many different fields. I've given a couple presentations to a couple NASA facilities. I've worked in, I've worked on automotive radar. I've worked military. I've done all kinds of crazy stuff. I've worked with lots of different controllers. Right now, I'm a pretty big fan of the ARM Cortex-M micros. Cortex-M family is specifically for embedded microcontroller applications. And in short, I love micros. Okay? Now, I'm going to be up front with you guys. Okay? I, like anybody else, I have my own biases. The world of microcontrollers is so huge, there's no way I can know everything about everything. And I have my own biases. So I'll tell you up front, I'm not a fan of the 8051 base. I'm not going to talk about those today. I'm not really a fan of microchip picks. Now, I will give them some distinct credit. They've been around a long time, and you can still get a lot of their parts in dips, which is hard to do with almost anything these days. So if you guys like PIC microchip controllers, more power to you guys. Now, I admit, I feel bad if you're a PIC person. Who here is a PIC person? I do need to know that. Wow, we got one person. 2 people. Okay. Do you guys have the debuggers already? Or no? No? Okay. Well, I can't help you with debuggers, but I can help you with chips. I've actually got some giveaway 40-pin PIC micros, and Isaac here will be happy to pass them out to first. Make sure at least the PIC people get them first, because they're the ones that can actually use them. So these do require a not inexpensive debugger to actually work with them. So just a heads up there. But if you guys can get any use out of these, please do so. Okay. All right. So this is where I let you guys talk a little bit. Okay. So why would I be here at DerbyCon? Why would a single chip microcontroller guy be standing in front of you today? Well, I know 2 good reasons. What are your thoughts on that? Go ahead. Ooh, I like his answer. Go ahead, video man. Next answer, free entry to the DerbyCon. Okay, I'm a little embarrassed. No truth in that statement. Next one. Oh, he's on to something there, man. Okay, guys. All 3 of those guys, give them butterflies, man. Those are good answers. Okay, so you guys are really hitting on the two ones that I would highlight. One, microcontrollers are just a blast. They are a kick in the pants. They're fun to work with. The second thing is Internet of Things. Right now, you're surrounded by microcontrollers and all kinds of electronic devices. As a security person, do you care? Could care less. That's about to change because all of a sudden, all these devices are become self-aware and they're going to start talking on the internet and they're going to start broadcasting at 2.4 gigahertz and other nefarious frequencies. And what are they going to be doing? Are they going to try to access your access points? What are they going to be controlling? What are they going to be looking at? So the bottom line is I've been in the microcontroller world for a very long time. It's not all been purely microcontroller. I've done some PC stuff as well. But my world of microcontrollers is on a collision course with InfoSec because of this merger of everything gets to talk to everything. So You're going to hear more and more about this kind of stuff for that reason. Okay? How are we doing on time? Okay, let's see what you guys know. What is a single chip microcontroller? Can somebody give me a definition? Just throw that out there. Go for it. Give it a shot. That's one way to put it. Go ahead. Okay, that's another way to put it. Okay, go ahead. Yeah, that's a very practical answer. Go ahead. Okay. You go. These are up to pretty good. Go ahead. Computers. Now that's one I've seen on the internet. All right, guys, I got to do this to you. Here's my academic definition from this guy named Tharon Hall. Okay. A single chip microcontroller is an electronic device that contains all the essential silicon necessary to implement embedded control and a single integrated circuit. Now notice sometimes you may need crystals, you may need a few ceramic caps, but generally all the necessary pieces are in one chip, okay? Now let's talk a little bit about what that means, okay? So to the point that a lot of people are making here, it is, in a sense, kind of like a little computer. You've got a central processing unit, you've got program memory, you have RAM, you might have non-volatile storage. A lot of times that's in what's called double EEPROM. You have other nefarious modules that need to be in there to make a processor. But one of the things that's kind of different about a microcontroller as opposed to a CPU is you're also generally going to have lots of other I/O whose role is to allow that microcontroller chip, that logic, to take input from the world, perhaps other electronics, and drive outputs, other electronics, and/or things that drive things in the real world. For example, your car, right? You have an ECM in your car, and it's firing off sensors, reading sensors, firing off actuators, doing all kinds of crazy stuff. The world of microcontroller control is enormous. So there's a lot of different types of I/O that are available to allow the microcontroller to do its job. Some of the basic ones are general purpose I/O, that's ones and zeros, that's simple stuff. You get into some clocks, you get into a lot of serial protocols, okay? You have to deal with the analog world, so you can read analog voltages. Maybe you can convert digital to analog outputs. Something called PWM. Okay, so here's a bonus question. I've had a lot of double E's that can't answer this. What's the advantage of using PWM? Go for it. Okay. I can adjust my duty cycle theoretically with analog. Go ahead. Okay, you're getting close actually. Go ahead. Okay, I'm actually fishing for something specific. Go ahead. You guys are close. Okay, so believe it or not, here's a one way to look at that, and I've had a lot of double E's that can't answer this. So the biggest reason to use PWM is efficiency, right? Because if you have a power supply voltage of 24 volts and you need 5 volts output, whatever current that 5 volt load, you got to figure out what to do with the 19 volt difference between the two. If you use an analog output to where you say, I know, I'm just going to give this thing 5 volts, drop it down from 24, you've got 19 volts dissipated across your part. If you pulse that, okay, either the device is completely open, not conducting current, so not using any power, or it's completely closed, completely saturated, and there's very little voltage drop. The number one reason to use PWM, in my opinion, there may be other opinions out there, is efficiency. A unit that does an analog output at power versus one that does a PWM, you can tell by the heat sinks, right, which one's being used. You generate so much more heat that way. Now, here's one thing I want to focus on real quick before we move on, talk about some of the subsystems in a microcontroller. Memory protection unit. You will find some microcontrollers that have a memory protection unit. That is not to say they have an MMU or a memory management unit. Memory management units are a hallmark of things like embedded Linux, where you need to be able to do like ring level control, partitioning, protection of different memory segments. That is really more of the realm of application processors. Things like the Cortex A family, right? You're talking like your phone or your laptop. That's a whole different class really of controller at that point. So, All right, now how many people here have Arduinos? Just get a little hands. Okay, good. I thought there would hopefully be quite a few people. So let's take a quick peek here. And I apologize, this probably doesn't look really good on the overhead here. Doesn't look good here either, unfortunately. But let's take a quick peek at the 18 Mega 328. That is the processor in the Uno. And here you have what you expect to find, the typical needs for processing. Essentially, you've got the AVR CPU. You've got flash memory to store your program. You've got SRAM to execute your memory, to store variables and so on. You've got a lot of sundry logic here. You actually have double EEPROM to store non-volatile parameters. And at that point, you've got kind of a fancy computer. But beyond that, you start getting to things that are a little bit more specific to microcontrollers. You have general purpose I/O. But you also have things like USARTs, which is basically a UART with synchronous functions. You have a SPI, which is just kind of like a fancy shift register. TWI, which is their name for I2C. Things like analog comparator. Again, we're talking to the analog world. You've got interrupts. You've got A to Ds. Timer counters, which are a little bit more complicated to talk about. They're not too hard, but they're probably a little bit more than we want to get into. So, okay. So, great. We got a bunch of Arduino people here. That's fantastic. I love hearing that. I own an Arduino Nano. I do tinker around with it a little bit, okay? But given that I've been doing microcontrollers for a very long time, I'm already playing with other things. So I personally haven't picked up on the Arduino too much. Let's give you guys a chance to talk. What are you guys doing with your Arduino? How would you describe the development environment? And would you recommend it for Mr. Johnny Long's hackerspace? Go for it. Mm-hmm. Right. Well, and I tell you, things have come a long ways towards making things easier, even for professionals that use these tools all the time. But I tell you, there was a day where, we did all our stuff, command line and text editors, and we hand edited make files. And really, one of the things I've noticed that Arduino has done is it's taken some of the headaches out of getting an environment together, and they streamlined it to make it easier for somebody to just walk in and all the tools are there. It encourages you to go in there and play. Go right ahead. Oh, there you go. Is it on? There is an on switch. There you go.
Thanks, guys. That's why I couldn't
There
turn
you
it
go.
on.
I hear you. Go ahead.
But yeah, I mean, the thing that the Arduino really helps me with is you search for Arduino and then whatever you want to do, and you can find somebody else that's already done it.
Right.
And
Right.
it's really easy to learn that way.
Yep. Very good. Very good. Go for it.
It lets you take.
Go ahead. Yeah.
I like how it lets you take the logic parts of circuits, which again, I'm a programmer. I'm not an electrician. I'm just playing around with the tutorials with Arduino, but I'm able to bypass some of the more complicated logic components of trying to put together something on a breadboard and turn it into code, which I completely understand, and can put all that together and get feedback from, understand what's happening, and work from there. So I really like that part of it.
Yeah, what I like about it is that it's fairly hard to break. And they're pretty cheap, so if I do manage to break the thing, get another one, no problem.
Okay. Now let me share something quickly with that comment, because you made a good comment, and this is probably important for folks to understand. I actually got some of this feedback from an AVR factory guy. The AVR itself, the microcontroller in the Uno, okay, notoriously or famously hard to break. Those boogers are rugged. The guy told me, this factory guy told me a story of some company that was trying to break an AVR, and they couldn't do it. They could not get the thing to break. Now, I will caution you, though, like anything else, dies had been shrinking, and gates are getting smaller, and as a rule, things are getting more sensitive. So if you want rugged, AVR is a great choice. But if you're going for fast, the latest and greatest, you're going to get into more fragile processors just because of the technology. That's just the way things are going. So, next person.
I kind of suck at soldering, so when I want to do some hardware stuff, I'm really a software guy. I need to do interface with SPI, or SPI as you call it.
Yeah.
So, yeah, it really allows you to connect a chip to it without doing any real soldering and just use a breadboard. And yeah, when you're not a hardware guy, yeah, soldering is...
Yeah, so I'm an electronics engineer, so the Arduino has basically enabled me to... I'm an electronics engineer, so the Arduino has enabled me to start programming more easier and to interface with the stuff I like to do. So I've been using it to as a wind turbine and charge controller. So it's a really neat thing. I love it.
Or watch our time here.
So I took sort of a strange tack with this. I actually started off on the PICs years ago.
Oh, okay, good. Okay.
Had kids and just lost the time to do that kind of stuff. The awesome thing about the Arduino is you've got all those libraries there. So you're not having to develop everything from scratch, either an assembler or, if you, like I did, pay for a C compiler. So it really gives me that time back to go create cool shit. And the ruggedness. I mean, I run this thing on a board that's got 1,000 volts running around on it to drive a Geiger tube. And a buddy of mine actually started creating these kits, and I started working with him, and we created this open source project on it, and I never could have done that. And, hung out with the family still.
Oh, I can appreciate the family time. I've got 4 kids. Isaac's not my only child, so. Hey, great, guys. I appreciate it. That was a great testimonial for Arduino. Hey, this is my list. I think you guys covered a lot of this. Obviously, reducing complexity made it a lot easier to get started. And made all this inexpensive hardware available so you could blow one up. You can just throw another one at it. Huge selection of just options. The open hardware approach really is just proliferated. This is a huge driver in the maker community. It's amazing how much, you almost associate Arduino with the maker community. Let's see. Believe it or not, the ease and use of Arduino has actually influenced the mainstream vendors. The guys that, those of us who have been professionals doing this for a long time, they're being influenced by Arduino, believe it or not. So, and there's just awesome community support. Now, I gotta ask this. Okay, so, any of you guys that play with Arduinos, have you met an electrical engineer that actually does embedded controls? And you say, play with Arduino? And if so, what kind of reaction did you get? Go for it. I'm not a big fan of parallels, but that's okay. That's okay. Anything else? I know you guys have had this experience. What do you get? Really? You don't even know what it is? Oh, that's kind of fun. Oh my. Anybody else? Okay, that's good. What I expect to hear is, I went up to this double E guy and I said, I got Arduino, and he's like, duh, why would you be using Arduino? We use real tools, Yeah, and I expected somebody to actually get that response. I'll just caution you guys, part of what I'm going to talk about is you're really running more in their pack than they probably would want to recognize, okay? But you're generally not going to get people who are going to go, well, you've joined the club, thank you for using an embedded controller. And that's unfortunate, really, because, look at the anatomy of Arduino Uno. It's got essentially all the goodies that I'm used to seeing in a professional development board. A low cost board, perhaps, but there's really nothing, and here's the key. I want to key on one thing here. One of the things that you guys have in an Arduino Uno is this bad boy right here. Now, because you guys are programming through a bootloader over 232, you may not even know what this guy is. This is an in-system programmer, but it also gives you access to debug wire. Okay? And there's pros and cons to debug wire. But the beauty of debug wire is it allows you to do professional level debugging of your Arduino board. So forget Arduino. I could take an Arduino board, take the bootloader off, and use it just like any other developer board that I can professionally use. Okay? Hold your hand up proud. Okay? You guys don't have to. You don't have to put your head down when you get around the double E's because you're really using a tool that's comparable to what we guys use. So there are a couple things you need to add though to do the professional level programming. So you'll need a debugger. Okay, there's various options. I'll caution you. Atmel isn't the cheapest approach, but there are some pretty decent debuggers. The AVR Dragon is my personal favorite. It's not the fastest, but I've used one for years and I really like it. Atmel has a new debugger that's supposed to cover both their ARM line and their AVRs. I don't know. It's fairly new, so I'm a little more leery about recommending it. And then there's one more thing. There's Atmel Studio, which is their professional development environment. And guess what? The price is right. It's free. Okay? Now, a news flash for you guys. I don't know if this is even out yet. It might be out now. They've been talking about this for some time. There's something coming out called the Arduino Zero. Okay? This is based on an ARM Cortex M0 Plus in SAM, which is Smart ARM Microcontroller, which is Atmel's marketees for their ARM line. Okay? It's coming out with an Atmel ARM Cortex M0. It's actually SAM D21, I believe. And what's great about this, it comes with the debugger. So you don't have to run out and buy a debugger. It's actually on the board. So that investment in the debugger is taken care of. All you have to add now is Atmel Studio, and you can start doing some really cool things with it. And this is a direct quote from my Atmel FAE. It's supposed to be very affordable. What that means, I don't know. $20 is very affordable to me, but I don't know. Now, I will tell you that there is actually the Arduino Do, I believe. And it is also an ARM processor. It's out now. It's about $50, I think, on the street. Not real cheap, but it's a pretty powerful chip. I've actually used that chip a little bit. That's on that. It's not a bad chip. A little bit more expensive. I do know if you go into Atmel Studio, there's a lot of example code specifically for the Arduino Do. Let's hope it comes out for the Zero as well. I couldn't get any confirmation one way or the other, but I'm hoping there'll be a lot of stuff in Atmel Studio specifically to support the Do. Okay. Do the Do. Okay, now, this is actually, I added this specifically for Johnny before we exit the Arduino section of this talk. So, it's hard to call it a language, but there's a programming paradigm called Scratch that was invented by MIT. And I'll try to get my pointer here to kind of point this out. It's kind of hard to see, I realize, but they came up with this more of a graphical representation of programming. It's specifically designed for younger children, but it teaches the basic principles of logic and programming. So there's really no reason that, for example, an adult couldn't use this. And just to let you guys know, No Starch Press actually has a book specifically on Scratch. I did buy it last year. Looks pretty good. I'd recommend it if you want to learn more about Scratch. What this team called Scratch for Arduino has done is they take the Scratch programming environment that runs on your PC, excuse me, and they download a sketch specifically to the Arduino, so the Arduino talks to Scratch. Then it shows up like it's a sensor in your Scratch environment. So therefore, you can use this graphical programming language to control or read your Arduino. So you're learning very simple programming paradigms, and you're talking to hardware. I added this, Johnny, because I thought, you know what? If for technical geeks like us that grew up being exposed to computers and how things work, some stuff may seem obvious to us, but I'm a firm believer that most people can learn technical things if you present it the correct way. This may be the first step you might want to consider. Start with something very graphical like this. See if they get the concepts. Maybe then moving into Arduino. That's one option you might want to think of. So there we go. Okay. I won't have much time for a quick Q&A. Anything you're just dying to get out, because as I was afraid of, we're running kind of long. So, and we're not going to run over. I'm going to make sure of that. We're good. We need the time. Okay. All right, going pro. You guys are going to graduate to the big leagues now. Okay, so the Atmel Studio, as I mentioned, the price is right, completely free. Now, it's built on Visual Studio. Who here has used Visual Studio? Oh, that's good news. Okay, because I had only dabbled in it a few years back, so it took me a little bit to get comfortable with it. But if you know Visual Studio, there's a lot of powerful tools in there, like Visual Assist, I think it's called. There's the standard stuff like highlighting. There's a lot of very powerful tools available. In addition to the tools, there's also a lot of plugins that are available that are kind of really part of the Visual Studio community, but they're also then available for Atmel Studio. So, and one of the things on here is that I want to highlight for you guys. There actually is a plugin specifically for Arduino that you can put into Atmel Studio. Okay. Now, here's the cool part. You can do with the plugin, you can do Arduino development within Atmel Studio the same way you do it with their IDE. Here's the next level. Now follow me. This is a sleight of hand here. It's a little tricky. Who here's a hacker? Got any hackers here? Hackers, we got a few. Okay, good. This is a little bit hackish, right? If you feel really safe in Arduino and you're afraid to venture out, this might scare you. But the bottom line is the Arduino IDE is built on the same GCC compiler that Atmel Studio is built onto. So the libraries that get generated by the Arduino IDE are actually compatible with Atmel Studio. You just got to figure out how to tie them into that environment. Okay, so I did take a look at this. I haven't tried it myself, but there's some reference material out there on how you can actually compile within the Arduino IDE the library for the target processors you want. You can bring it into an Atmel Studio project, and now you can call all the libraries in Arduino that you're comfortable with, but you have access to all the power of a full-blown professional IDE. Does that sound cool? Somebody think that sounds cool? Yeah, that's what we need to hear. All right. All right. You gotta wake up Johnny. I think he's sleeping over here. Sorry about that, Johnny. You've had a long week, dude. I appreciate you being here, man. I really do. That was a hooray. Yes. Yes. All right. Okay. All right. Okay. We got a what say ye. I love these. Okay. So I know the answer to some of these because some people have used Visual Studio. Who's used breakpoints, single stepping, watch variables? Who knows all that stuff? Fantastic. Okay. So if you're in the Arduino world, you play with stuff, you download it. Does it work? No. Let me go back and read the code again. Why didn't it work? I don't know. Let's try it again. That didn't fix it. I don't know, right? Hey, look, I can start doing some printouts. Okay. Does that get what you know? Isn't that what I need? Okay. Now, the beauty of, one of the beauties of a professional development environment is all that ability that you're accustomed to in PC programming, where you have full control of the program. You can stop it. You can watch variables. You can adjust values. You can set a breakpoint. All that power is available to you in a microcontroller, okay, with the right tool set. You have what's called essentially a debugger, not just a programmer. Be careful. There's programmers that don't allow you to do debugging. But all debuggers allow you to do programming. So if you're interested in debugging, be sure you get a debugger. But all that power that you're accustomed to in PC programming is available to you through the magic of onboard debugging modules. So, let's see. Watch change variables. Let's see if I missed anything. Oh, I will mention I have trace in quotes. There's supposed to be new trace features in Atmel Studio 6.2. I think it's called Precipio Trace. That looks appealing. I haven't tried it. It's the only reason I put it in quotes. I can't vouch for it. There is actually an AVR simulator. Now, I want to mention this because if you think, hey, I want to play around with AVR programming, you can run a simulator in Atmel Studio. You can play for free. You don't even have to have hardware. So I want to mention that. Okay, we're ready for this? Okay, now, oh, I went too far. Okay. Man, you weren't ready for that. I'm sorry. I wanted to make sure run away. Well, okay. I wanted to make sure that I had, get you guys ready for this, because this is an eyesore slide. I tested this on the projector Friday, and I went, oh, this is awful. I apologize for that. It looks great on my screen. It looks horrible up there. So hopefully it's a little better on the video. But I did want to kind of give you a sense for, okay, this is a real environment. And you got all of the wonderful toys that you'd expect to have. For example, you can look at the call stack. You find yourself in a weird place. How did I get there? You can actually look at the call stack. You can set breakpoints and see your breakpoints. Where am I at? You can look through memory, actually analyze the memory contents. And this is kind of interesting because this is not something you typically, I probably get a lot of exposure to in just Visual Studio doing PC programming, but you can actually look at the values of the registers. Okay, all that magic hardware, that magic glue that makes a microcontroller really a microcontroller. And I tell you, the devil's in these bits. Okay? If something ain't working, it's in those bits. I mean, I've spent half my career, it seems like, chasing those bits in there. So you will use those. And that's one of the things you don't get with Arduino. You don't get that view under the covers to see what's really going on down there. And of course you have all the standard stuff. Step over a function, step into a function, step down. For example, you can see here, there's a breakpoint set, and here's the cursor. This is where the execution is actually taking place. Now, and then there's a sad face here. He's a little bit sad because I'm embarrassed by this code. I got to be upfront with you. I had done a project, and I whipped this thing together, and I think my formatting was off initially, and I fixed it, and then I looked at the slide and went, that code is evil. I pride myself on readable code. Is my code readable, Ed? Okay, Ed confirms my code is readable, so we're in good shape. Now, this is a really good segue. Let me share something with you. Now, I got to tell you, this is my Johnny Long moment, okay? This is where, we're going to have some, okay, Ed, this is where you come on, everybody. Okay, so, I got to share a story with you guys. In May, my best friend, okay, was in a head-on collision out on a country road. It was so head-on that the two vehicles came to an absolute complete stop. They were tire to tire, dead on. And he was slightly injured. His son was slightly injured, but his daughter had a broken femur, which, if you don't know, is actually life-threatening. And she was airlifted this was out in the country in southern Indiana. She was airlifted like an hour here to Louisville. And she's fine. She's doing okay. But she does have metal plates in her leg. Okay. Now, I had metal plates from when I was 20 playing football with a bunch of guys at the farmhouse. And we don't need to talk about that. So, one of the things I wanted to do, I wanted to make her feel good about, hey, it's all right. Things happen. And so I said, hey, you're part of the Cyborg Club. By the way, she's 9 years old. You're part of the Cyborg Club now, And I wanted to do something, like hackers did it. Hackers did it. Okay, so I want to do a hackery kind of thing because it's something I can do that's kind of different. I want to do something to make her feel special, kind of make her feel a little bit better. So what I did is I created let's get it going here, Ed. We'll do it. I know it's, okay, very hackerish. Use a jumper for almost the place. That hacker. It works great. Let's Ed learn it. Okay, there you go. Now be careful. This is how blinding you're supposed to do it. So, okay. So anyway, I thought it'd be nice to see you guys. Hey, hackers can do good things in our life, right? We can use our stuff for the power of good. This is actually an AT-Tiny 84 8K flash, which is overkill for this, but I thought, why not just buy the 8K? By the way, the AT-Tiny is a good line for doing that kind of stuff. Now, I wanted to tell you guys, I had a couple young ladies that I was hoping would kind of come in and fill in for me and stand here, and they couldn't make it. So I thought Ed would have to substitute. So I appreciate your being gainful there, Mr. Ed. So, woo! All right. So, and thanks to Aaron for letting me borrow that back just so I could show you guys. So, well, running out low on time. Okay, so you guys can play with Atmel Studio. I'm going to start going fast, in part because the video will pick up all these slides really well, okay? So don't worry if you don't catch something. You can go back to the video and review it. There won't be a problem, but we got a lot of material I'd like to at least brush through here quickly. So, all right, so Atmel Studio has something called the ASF, which is the Atmel Software Framework, which is kind of a standardized way of talking to things. It's a little bit like the Arduino library in that you can just pull the jumper off. You don't have to stand there and hold it the whole time. Anyway, that's going to blind somebody. You should leave it. Let's just let it flash and be fine. But there's all kinds of different projects that you can pull up for different processors and different kits. I'm a big fan, and I think most people would be. I'm a huge fan of finding a kit that's the closest to what I want to do, get it working, and then modify it. It saves you so much time than I'll just throw a bunch of stuff together and hope it works. That's painful. So, this is really cool. One of the things I really like about Atmel Studio, they added this thing called Atmel Gallery. This is a way that you can download the plugins into your development environment. And again, I've highlighted the Arduino plugin here. By the way, that's not free. There's an evaluation period, and then, then it's money, unfortunately. But, and I haven't explored this much, but there's something called Atmel Spaces. I think this is fairly new. This is meant to be kind of like a community. Oh, I'm getting a 10-minute warning. Wow. All right, that's scary. Okay. Now, here is a couple things I want to point out. If you have not stumbled across AVR Freaks is the granddaddy of all fan-based micro supports. I chose AVR over PIC for a product in part because of AVR Freaks. There was so much fantastic support there. I mean, when there was almost no support, there was AVR freaks. These guys are incredible. Now, at91.com is, I think, meant to parallel that a little bit for the SAMs. You can't beat AVR freaks, though. I mean, it's hard to go there. Now, we're running out of time. Just suffice to say, there are a huge number of really good kits available for Atmel. The only thing I'll just caution briefly is Atmel Store has some good prices on things, but the shipping tends to be kind of high. So on a onesie-twosie basis, you may still find it's cheaper to get from DigiKey as opposed to the Atmel Store. So, okay, I might blow through this because we're down to one. We're going to be down to one Q&A anyway. So, you go to DigiKey and you search microcontrollers. You get over 44,000 matches. The incredible world of micros, guys. There's a lot of stuff out there. Resources on the web. There's a lot of good stuff out there. Again, check the video. I tell you what, if you ever get like bummed and like, oh, I'll never get microcontrollers, they're just driving me crazy. I just need like a pick-me-up. Go to Hackaday. I mean, if you just want inspiration, Hackaday just rocks. There's just so much cool stuff on there. And, if you want a good laugh, check out Mariano Philippa's blogs. Could you take a stand, Mario? Come on. Let's everybody see you. Yay. Mariano is really a hardware guy. So he's got the different stuff on there. Some stuff I'm begging him to get done, but he's got a life. So, but his hardware stuff is really good. I was really impressed with that. I do want to highlight one more thing. This gentleman here, Mr. Jake Carlson from University of Nebraska, Lincoln. Go Huskers. Thank you very much. He's got a really good article. If you want to get kind of a overview of the different kits out there, I thought his article was really, really good. He actually taught me a couple things from that. So, okay, where to buy? You guys may know all these. There is the Atmel Store, Adafruit. I'm sure a lot of you guys are probably familiar with it. Spark Fun. Those guys have been around forever. They actually preceded Adafruit by quite some time. And DigiKey. Who does not know about DigiKey? Learn DigiKey. If you need to buy electronic components, nobody on the planet matches DigiKey. China orders their quick-turn stuff from DigiKey because they can't do it in China. No, I'm not exaggerating. It really is true. So, okay. There's lots of good forums out there. ARM itself, of course, they want you to use their processor, so they have all kinds of community support stuff. Tons of forums from vendors. Okay, I'm running out of time, and this is sad because this is so cool. If you like Arduino, do yourself a favor and check out embed.org. Okay? Embed.org is much like Arduino, but this is kind of cool how they do this, really. Their compiler is online. So you log in, you go play with their compiler, and when you want to download the code to your device, oh, by the way, there's some cool kits there. Oh, okay, that's my bad. I'll just talk ahead. If you want to download to your device shows up as a USB drive. You just take the binary image that says save, and you save it there, and boom, it loads it. That might even be easier than the Arduino. Okay? They've got tons of kits. I'll just show you really quickly. I'm getting ahead of myself again. So NXP has kits that support this. Freescale supports it. ST supports it. Nordic and a whole host of others. Some great kits out there. I'm going to highlight this one real quick. This kit right here, this is one of the more expensive kits, but it's a wicked kit. This is the K64F. I've got a couple of those I can't wait to play with. And guess what? They use Arduino headers, right? So if you've got Arduino shields, there's a pretty good chance you can get it to work with the embed parts. Nucleo, the ST Nucleo, that's a really good set of boards as well. They're some of the cheapest ones out there. Freescale again has some good boards. NXP had a 28-pin DIP in an ARM Cortex M0, and they're phasing it out. Thus the sad phase. And look at this. The Nucleo boards, they start at $1033 at DigiKey. The Freescale boards, $1295. Why don't you hand out a few of those, guys? Get some. I've had so many good answers. I apologize. There's so many good answers. I wish I had more to give out, but try to look for people that have given answers at least, right? Make them earn it, right? But we're running out of time. Okay. So just a quick. It's like. Is he still talking or? Hey, Johnny's been a good sport. Make sure he gets one too. Johnny's really been a good sport. Make sure Johnny gets a board. Okay. And this is just a quick, I'll obviously, the video guy wants it. Can I have a kid? Oh, it's 5 minutes. I'd like to tell me, I want a board, man. Give me a board. He's telling me 5 minutes. Okay, I'm with you. Okay, so here's the compiler online. Looks like a compiler. Here's the download. We talked this through. Now, here's one feature I really want to talk about, because this is one of the things that makes embed something that you can't do with Arduino, at least not easily, okay? One thing you can do, and this is not universal, I'll warn you, you can take your project from embed that's online and you can export it to an external tool. So in the case of the K64F I told you about, you can actually have your project and you can export it to the completely free Kinetis Design Studio, and then you can work on it at the local level with professional tools. You can do all that debugging that we were talking about. So, and I am so woefully out on time. Okay, so who here is a big ST fan? Do you even know what ST is? Who would like a free board? All right, give that girl. All right, these two guys are my groupies, man. They're going to get some stuff. So, all right. So what I'm going to do is I'm going to quickly flip through some slides here, because they'll get captured on the video, okay? And while we're doing it, why don't you see who wants some PIC controllers? I don't know. You can like squish bugs with them or something. So anyway, there's so much more we could talk about. As I was afraid of, we're running low on time here. But free RTOS is a good RTOS to look at. There's a really, but now listen real quick, because this is cool. There is a POSIX compliant single chip microcontroller embedded operating system called NutX that even Ed says is impressive, and he knows his stuff. I'm becoming a big fan of the Kinetis line, actually, of the Freescale stuff. Quick thing to throw out there. What the world needs is a good, cheap, breakout board for Kinetis, because you can't get dips anymore. They're basically drying up, so that's something to think about on Twitter or whatever. And see, and ST even has a Java solution, but it's very expensive. You can even run JavaScript. Okay? Now, here we go. Here's the big challenge. My goal was to get at least half of you guys playing with microcontrollers when we're done. Now, Arduino counts technically, but I'd like you guys to kind of take it to the next level, so it's your choice in your journey. So I'm not quite done, but don't get too excited. This kind of stuff happens. People lose control, jump off buildings. I don't know why this thing even exists, but who's going to jump off of a tower? Okay. All right. And of course, here is my website. So eventually my talk is going to go there. It's technically there, but I haven't, Google hasn't found it yet. And, okay, we got just probably a couple minutes. What, about 2 minutes maybe? Maybe about 2 minutes. See what more we can do, guys. What's up, guys?
There's one great website called dangerousprototypes.com. It's kind of like Hackaday, but it's also got a lot of good Arduino projects and things like that, too.
Like you said several times, there's so many microcontrollers out there. How do you even start going about picking one?
Oh, boy. I have that trouble. About 2 years ago, we went through an exercise where we needed to change microcontrollers, okay? We ended up sticking with Atmel, okay? Because we've been an AVR house. There's a lot of different reasons there. We had some great support, really. I mentioned we talked to factory people. If you guys, and I need to say this too, if you guys are comfortable with your Atmel kits and your AVR kits, you guys are not going to go wrong sticking with Atmel. I would not discourage you from using Atmel. But they're not the only player out there. I personally really do like the Kinetis. They have a good line. The pricing is good for the performance that you're getting. I love that they really come out with the Kinetis Design Studio. I'm a big fan. Now, a lot of people, do you guys want to talk to ST real quick? You guys really like ST, but it's hard for the hobbyists to work with ST because of the toolkits. I don't know if you guys want to put any words in for ST at all.
Is this working? Oh, yeah. Okay, so we use ST a lot, and that's just because we came from consumer appliances kind of industry and stuff that was high volume, low cost, and so it was a lot of bang for your buck. And, they've got a really nice line of stuff. Compiler support, they're a little lagging behind the free compiler stuff. Everybody else seems to be moving to the GCC stuff. So, but,
right.
But bang for your buck, and if you need to make a trillion of something, you almost can't beat them.
Yep. I know the hardware side is good. And, I'm getting the big X. Okay. Can we squeeze in something real quick or no? Sure, something real quick. Okay. One more extra minute. Go ahead, sir.
So what are the main challenges of porting code and components between these different microcontrollers? Wow.
It's painful.
You got a minute.
Your logic code, generally you're generally going to be writing in C. You may be able to get in some C++. That logic code will port, but all the peripheral stuff is completely different. So it's not good. You generally, once you lock into a microcontroller family, you generally don't want to change. And especially professionally, it's just painful. All right, real quick. I think you're going to the last one. No. It's Visual Studio based, so it's going to be good. Does it run online? I doubt it. Come on, Johnny. I'm sorry, we're going to go over time. Johnny.
Well, we won't go real far, but first of all, big round of applause for Tharon. This is a great talk. So super quick, I'm really excited to have this thing. I'm like really excited to play with this. As soon as I saw Scratch, I was like, okay, there's hope for me, right? So you guys heard that I want to try to do a hackerspace in Uganda. So now I have this thing, and I watched this talk, and I'm like super excited, and I'm ready to like geek out. And I have no clue what I'm doing, and I have to go back to Uganda and teach kids how to do it. So therein lies my challenge. I'm looking especially to guys like Tharon and people in this audience. When I'm out of sight and kind of out of mind back in Uganda, I'm going to need some help. Because I got a bunch of kids that want to learn this stuff, and I have clue minus, and I'm totally going to need your help. So thank you for shining the light on this. I get to learn by myself. Hopefully you guys will help me out as I try to help kids over there. But thank you guys so much, and thanks, Tharon, for the great talk.
Thank you. I appreciate it. All right, I think we're going to have to close. We got one last thing. Who needs it? This is NXP. So these are going to be